Welcome to CE 405 Environmental Engineering 1 Module 5 Part 1. In the previous module, we learned about the filtration process in water treatment system. The next process is disinfection. What is the requirement of disinfection in a water treatment system? In the big or large type of water treatment system or the community with a large population, large water treatment plants are designed. In these water treatment plants, the rapid sand filter is used for filtration process. But in rapid sand filtration system, the bacterial removal efficiency is only up to 90%. So we have to remove the 100% bacterial content from the filtered water. In order to consider the health effects, health hazards caused to the public due to the impurities present or the bacteria present in the water supply system. So we have to provide a disinfection system in a water treatment plant. This is a requirement of disinfection. The chemicals used for disinfection is known as disinfectants, and the process is known as disinfection. Then requirements of good disinfectants. They should destroy all the harmful pathogens and make it safe for use. It should not take more time in killing bacteria. It should be rapid action. Action should be rapid. They should be economical and easily available. In our household system, we are using bleaching powder as disinfectant. Before the rainy season, we are adding a small amount of disinfectant into the well water. This is a disinfection done in household activities. And these should not require high skill for their application. After treatment, the water should not become toxic and objectionable to the user. That is, if there is a smell or any other difficulties related with the disinfectant. Basically, the disinfectants are chemicals, and these chemicals cause any of these difficulties. We cannot use that disinfection for our water treatment system. Then methods of disinfection. Chlorination is the most accepted and worldwide used disinfection method, and different types of chlorination are there. Different chlorine generating chemicals are used for chlorination. And the second is the boiling, then adding excess lime, then treating with ozone, adding iodine and bromine, adding potassium permanganate, and the last one is electrocatalysis process. In this, the chlorination is the most accepted one. This is because the cost of chlorination, that is the chemicals used for chlorination purpose, is very cheap. So every system can accept this disinfection method. Chlorination is the addition of chlorine to kill the bacteria, and it is widely used. And in chlorine is available in the form of gas, liquid, and in the form of solid. In the form of solid, it is known as bleaching powder. Then chlorine is known as the universal disinfecting agent. Then precautions while using chlorine as a disinfectant. Chlorine gas or liquid is highly corrosive. So we have to take care while using chlorine gas or liquid as a disinfecting agent. So it has to be stored carefully in a sealed container at a distance. If the water contains phenolic compounds, if the raw water, that is the water we are treating, contains the phenolic compounds, it will react with the chlorine and it will cause the cancer causing chemicals or cancer will be an after effect of using this treated water for our daily consumption. Then behavior of chlorine in water, that is the disinfection action of chlorine. When chlorine is dissolved in water, it forms hypochlorous acid and hydrochloric acid. That is, it is in the form of gas or liquid. That is pure form of chlorine. That is Cl2. Then Cl2 plus H2O. When it mixes with water, it forms HOCl, which is the hypochlorous acid plus HCl. This hypochlorous acid has a highly disinfecting action, and this causes the disinfection of the water that we are treating with this disinfectant. After some time, this hypochlorous acid further ionizes and forms OCl minus ions. That is HOCl split into H plus and OCl minus ions. This hypochlorous acid, that is HOCl and OCl minus, is the main disinfectants that helps the disinfection action of water that we are treating with these disinfectants. Similarly, when chlorine is added to water, it reacts with water and consumed by ammonia. If ammonia is present in water, then it consumes this chlorine and convert into hypochlorous acid and chloramines. These chloramines are monochloramines, dichloramines and trichloramines, and these chloramines are released in the water, and which depends on the pH value of water. When chlorine consumes all the ammonia, the further addition of chlorine will result in residual chlorine. This residual chlorine will help in the further disinfection which will come after the water treatment process. That is, the transportation of water from the treatment plant to the distribution system. A lot of distance the water has to cover, and during this transportation process the contamination may happen, and this will take care of by these residual chlorine present in water. The free chlorine and combined chlorine, that is combined chlorine is chloramines and hypochlorous acid, have disinfecting ability. Free chlorine has instantaneous effect on bacteria. That is, the action is rapid. But the chloramines, that is the combined chlorine, has a long-term effect. This compound enters into the cell wall of the bacteria and it destroys the bacteria. This is called the enzymatic hypothesis. Then the next is dose of chlorine. Dosage depends on organic and inorganic impurities present in water. And the dosage should be such that it should leave a residue of 0.2 milligram per liter. That is, the residual chlorine present in the treated water should be 0.2 milligram per liter. So, the total dosage to be supplied to the water treatment system for disinfection should be equal to chlorine demand of water. That is, chlorine required for cancelling or killing all the bacteria present in water plus the free chlorine, that is the residual chlorine. That is the total dosage required for a water treatment system. Then forms of chlorine added. Chlorine are added in different forms. The first one is the free chlorine, that is in the molecular chlorine, that is Cl2. It is added in the form of liquid or in the form of gas. Second one is combined chlorine. Combined chlorines are in the form of hypochlorite and bleaching powder. Then the chlorine tablets, then chloramines, then chlorine dioxide. The first one is the free chlorine, that is the free molecular chlorine Cl2. The chlorine used in the form of liquid chlorine or in the form of gas. The liquid chlorine is always preferred because it is more practical in the case of feeding device. That is the a device used for mixing and feeding this chlorine dosage into the water supply system. Then liquid chlorine mixed with a small amount of water to form a strong solution. This solution is stored in a solution feed chlorinator and it is fed into the distribution system. According to the requirement, that is the dosage required for the treated water, this feed chlorinator will dispense the amount of chlorine required into the water supply system. This chlorine gas is stored in a direct feed chlorinator under pressure and is fed directly into water. This is the free chlorine, that is Cl2. Then the hypochlorite. Calcium and sodium hypochlorites are generally used. Calcium hypochlorite, also called the high test hypochlorite, that is HTH, or the perchlorone. It contains 60 to 70 percentage of available chlorine. That is, available chlorine is the amount of chlorine available in the hypochlorite for the disinfection action. If we are taking some amount of hypochlorite, the 100% chlorine will not be released from that hypochlorite. Only 60 to 70% of chlorine will be available for the disinfection action. Then calcium hypochlorite react with the water to form hypochlorous acid, which is a disinfectant, and this process is called hypochlorination. The equation is given, that is CaOCl2 gives Ca2 plus 2 OCl minus. OCl minus is the ionic stage. Then this OCl minus combines with the H plus ion will give this hypochlorous acid, that is HOCl, which is a important disinfectant for disinfection action. Next form is the bleaching powder. Bleaching powder is chlorinated lime or calcium oxychloride, that is CaOCl2. It is a white amorphous powder with pungent smell. It has only 30% available chlorine. In the lab test, that is in the environmental engineering lab 1, we are testing the available chlorine in the bleaching powder. In that test, you can understand how much percentage of chlorine is available in that bleaching powder. In most of the cases, the available chlorine in the bleaching powder will be less than 15%, and this will decrease the disinfection action of the bleaching powder. If we are adding 30 gram or 50 gram into the water supply or our well, then the chlorine released from, that is the disinfection action, will be very less, and the expected disinfection will not take place in the water. Then next is the chlorine tablet. This is used for small purposes or instant purposes. That is, if we want to chlorinate or disinfect a particular quantity of water, immediately we can add chlorine tablet. And this is not commonly used because chlorine tablet is costly. So halazone chlorine tablets are used as disinfectant. Then the next is type of chlorination. Chlorination is done in various methods or various stages of water treatment system. The first one is plain chlorination, second pre-chlorination, then third post-chlorination, then double chlorination, breakpoint chlorination, superchlorination, and dechlorination. This is the 7 stages of chlorination that we are accepting or doing while treating raw water in a water supply scheme. The first is plain chlorination. If the raw water is not treated in a engineered way, that is normal screening, sedimentation, filtration, that process. If we are not doing all these treatment system, we can accept plain chlorination uh, if the water is clear, that is there is no visual pollution is there, and there is no impurities entered into the surface water, then we can adopt this. And in the case of war or any emergency situation, we can accept plain chlorination. In that, if the water supply schemes are damaged through bombing or any other hazards, then we can accept plain chlorination for immediate supply of water to the public. And it removes bacteria, color and organic matter, and it is used relatively for clearer water. And the dosage of chlorine is 0.5 milligram per liter or more. This is the plain chlorination. In the household purposes, in the houses, we are adding bleaching powder directly into the well water. This is also a type of plain chlorination. Then pre-chlorination. The chlorination is done before filtration or before sedimentation is known as pre-chlorination. This will reduce the load of filter beds, or will reduce the load in the sedimentation process and also in the filter beds. And the pre-chlorination is followed by the post-chlorination. The post-chlorination is done at the end when all the other treatment processes are over. The dosage is such that to leave a residual chlorine of 0.2 milligram per liter. If these two processes, that is the pre-chlorination and post-chlorination, is used in a water treatment system, then it is known as a double chlorination. The pre-chlorination plus post-chlorination is known as double chlorination. Then the breakpoint chlorination. When the chlorine is added to water, the residual chlorine amount, you can see the graph shown in the slide, that is in the x-axis, the applied chlorine is there, that is the amount of chlorine that we are adding into the water, and the y-axis is the residual chlorine that will be there in the water after adding the chlorine. In the initial stage, the residual chlorine will be 0 and the applied chlorine is 0. While adding the chlorine into the water supply system, the residual chlorine will increase. From A to B, you can see a smooth curve, that is in a direct proportionate manner, that is applied chlorine and residual chlorine is directly proportional, and after B the curve is dipping to C. This is because this this chlorine reacts with water and reacts with impurities or bacteria present in water, and which will reduce the amount of chlorine present in the water, which will result in the decrease in residual chlorine present in the water. When all the impurities are removed through this chlorination process and all the ammonia is reacted with this chlorine and formed the chloramines, and all the bacteria are removed, then the chlorine, after adding chlorine after the point C, the chlorine will be present in water as residue. This is the break point. That is, the point C is known as break point. That is, all the impurities, all the ammonia, all the bacteria are removed, and excess added chlorine will remain as residual chlorine. then the addition will result in a straight curve which is parallel to the dotted line shown in the graph. The dotted line is the chlorine addition in a pure water. That is, in pure water, there will not be any impurities, there will not be any bacteria present in that water. Then in that water, we are adding chlorine, then it will be directly proportional to the residual chlorine. All the chlorine that we are adding into the water will result in the residue of chlorine present in water. That is the dotted line shown there. And after the breakpoint chlorination, the amount of chlorine added will show a same graph similar to that of pure water. This is the breakpoint chlorination. Then the superchlorination. It is the addition of excess amount of chlorine, that is 5 to 15 milligram per liter, so as to produce a residue of 1 to 2 milligram per liter. It is used under special cases like highly polluted water or during epidemics. We during the flood season, in the previous flood seasons in Kerala, this method is accepted, that is the superchlorination. Excess amount of chlorine, that is a much more amount of chlorine larger than the residual chlorine present in water has to be added into the water treatment system to increase the disinfection action. This is to restrict or avoid the possibility of epidemic to the public. Then dechlorination. Dechlorination, it is the removal of excess lime present in the water. That is, extra chlorine is removed such that a residue of 0.2 milligram per liter do remain even after the dechlorination. And dechlorination is done by some dechlorinating agents. And the list of dechlorinating agents are given, that is sulfur dioxide gas, activated carbon, sodium thiosulfate, sodium sulfite, sodium bisulfate, and ammonia. These are the chlorination procedures, chlorination stages accepted in the water treatment system, that are altogether 7 stages. And this is an important topic in the disinfection, that is in the 5th module. And usually in the university exams, these questions are frequently asked, like breakpoint chlorination or the total chlorination process or the disinfection action, etc. are frequently asked in the university exams. By this, I am stopping this session. I hope you understood this disinfection action of chlorine and the various disinfectants and the disinfection action methodology of chlorination. And take care. See you in the next session. Bye bye and thank you.